Now, when looking at the degrees of freedom, we can find the conservative degrees of freedom for the in the previous problem. Now, when we say conservative degrees of freedom, it's an easier way to get the degree of freedom, but less accurate. To do this, we take n minus 1 from the smallest sample. So in this case, our n is 10 and n2 is 11. So our smallest sample would be 10. So our degree of freedom for conservative is 9. Now when we do this, we can find our p-value a couple ways. One way is we can look at the t-chart. And on the t-chart, you come down to degree of freedom 9, and you go over until you see the t-value. We got a t of 1.6. So you can see 1.6 is somewhere in between those. So we know our p-value is between 0.05 and 0.10. It's not that accurate, but it's accurate enough to tell us that we failed to reject the null at a 0.05 level. Now, a visual of this is what your t-distribution looks like with 9 degrees of freedom. And if the t is 1.604, then our p-value is this region over here. Now for a better degree of freedom, this is not an easy formula. You take standard deviation squared over n plus the other standard deviation. It's a lot. You can fill in all of this and get the degree of freedom that we got on our previous problem. This is more accurate. This is really more accurate. However, we will never, ever have to figure this out. This is for computers and calculators to figure out, not us. Now, this is quite accurate as long as the sample sizes are both 5 and larger. That's what we use for degree of freedom. Otherwise, we would use that conservative degree of freedom.